Finally, let's now consider the third kind of special function, bijection. And you can see given the function, but we don't really have to worry whether it's partial or total, because by its very definition, it must be total, injective, and also surjective. So it's not possible for a bijection to be partial. Okay. How do we call that? You can say a function is bijective, or a function is a bijection, or a function is a one-to-one correspondence. I should have both fixed this. I think I should do that when you download the slides. Anyway. And let's remind ourselves about this table over here, about checking the 2 dimensions over here, right? So you can see in the case of a bijection, you simply don't have this particular possibility. It's simply not possible, right? There's no such category, right? So we're just mentioning this just in time, okay? But for injective or surjective functions, definitely you have to know whether it's partial or total. But for bijective, by definition, it's only possible to be total, all right? Let's now go back to the slides. And of course, we're going to look at some example for the bijection. Okay, let's now take a look. And this is definition. Just keep it handy just for you. And let's now go over example. Okay. And the first one is, here I'm saying that, oh, by the way, how do we actually put the symbol? Let's talk about syntax. I forgot. Okay. The syntax will be, well, we're kind of saying that it's total. Okay, sorry. It's going to be total, meaning that it's going to be like this. So total is like this. This is a total function. Agree? Injective, focusing on the domain values. So that's going to be some tail over here. Surjective, focusing on the range value. So that means we're going to introduce an extra head. Right? So that's how I remember it. Otherwise, if you simply memorize it, just by how the symbol looks like, it's not it wouldn't lead you a long way. So I would say think about what each individual part of the symbol really means. I think that will help you a lot to really remember the symbol. Okay, and do you have this kind of a bijection? No, because it cannot be partial. All right, so that's the how you write on the paper. In terms of the ASCII characters, you can definitely refer to the slides. We may just look at that together at the end. Okay, let's now take a look at the example. The first one, this one here, right? Similar to what we said earlier about, I believe, this particular example over here. Similar, right? We said that this empty function is automatically an injection. Oh, actually not here. Sorry, I think it was this one over here. Beg your pardon. Over here. That's what I meant. Over here, we are saying that it's simply not possible to have a total injection from these 2 particular sets, right? And now we are making a similar example. We are saying that it's not possible to make a bijection from these 2 sets. Why? Well, similar idea. So let's say if you really want to build a bijection, how would you build it? Let's take a look. So of course, it's going to be total. So we're going to include 1, 2, and 3 in the function. So 1 here, and also 2 here, and also 3 here. Right? It's already total. Can we make it injective? Well, unfortunately, we cannot. Because similar to what we said before, if you put, for example, A and B here, so far it is okay. But what about this particular third elements? It doesn't matter if you put A or B. If I put A, for example, in that case, you got 2 range value being mapped from unique domain values. So that will make it not injective. So it's not possible to really build a total or just to build a bijection from this particular 2 sets. All right? Very important for you to see why, right? Hopefully that helps. Let's look at the second example. The second, actually, we got 2 parts for the second example. The first part, this function over here, right? Well, there are 3 things for us to check: total, injective, and surjective, right? I think it's very nice page over here where we talk about bijection, so we can synthesize about all the earlier definitions. First of all, total. 1, 2, and 3. Exactly equal to the first set. It is total. Okay. Injective. We got unique range value over here, A, B, and C. So the antecedent for that injective property is simply just false, right? So in that case, it will be true trivially. So again, A, B, and C, they're simply just unique, so it's injective. What about surjective? We got A here, we got B here, and also we got C over here. In that case, it will be exactly equal to the second set, right? So that's total, injective, and surjective. Of course, I think your math teacher earlier liked to draw this kind of one-to-one correspondence. I'll just draw for one. I personally don't find this very helpful sometimes, but even though we got some exercise for you anyway, okay? So you can think about 1, 2, and 3. So everything is here. So this is the domain, and this part over here is the range. And also we got A, B, and C. And we definitely got 1 maps to A, and also 2 maps to B, and also 3 maps to C over here, right? And that's definitely one-to-one correspondence over here. That's exactly maybe why it is called, because you can see visually it's one-to-one correspondence. Let's now take a look at the second one. Over here, that is also total, injective, and surjective, right? Very quickly. Total, because 2, 3, 1 over here, exactly equal to the first set. It is total. Injective, A, B, and C are simply no duplicates over here, so it is injective. And also A, B, C exactly equal to the second set. In that case, it is surjective, right? You can visualize like that if you wish. All right. Let's move on to the next one. The next one, let me use pink. Let's now say this is the function we are talking about over here. Again, let's is it total? We got 2, 3, and 4. So 2, 3, and 4 is not exactly equal to that particular first set, right? It's not. So not total. Is it injective? We got B, C, and A. No duplicates. So it is injective. And what about surjective? We got B here, we got C here, we got A here, exactly equal to the second set. So it is surjective. Right? So this particular function here, if you want to justify why it is not a bijection, you should really say as detailed, at least as detailed as like this. It is not total, even though it is injective and surjective, right? 3 criteria for you to judge. All right, let's now move on to the second one. The next one. Let me use orange. Okay, over here. Okay, good. Let's now try to judge again. Is it total? 1, 2, 3, and 4 over here. Exactly equal to the first set. It is total. Not a problem. Is it injective? A, you can see A here, they're duplicated, and they're actually mapped from different domain values over here, 1 and 4. So they are not injective, right? To see the detailed definition for injective, I'll refer you to the earlier part for the module this week. Okay, so it is not injective. Right, we already done the very detailed walkthrough about injective function judgment earlier, so I'm being a little bit fast over here. And what about surjective? Well, you can see A here, B here, C here, and A here. So A, B, C, exactly equal to the second set. So indeed, it is surjective. Right, so this example here, in conclusion, it is not a bijection because it is not injective, even though it is both total and surjective. The final example, okay, so which color should I choose that can that would deserve to be the final color to put here? How about purple? Okay, let's put purple over here. Oh, actually too much over here. All right, what about the final one? The final one here, again, one by one. Is it total? Is it injective? Is it surjective, right? Is it total? 1, 2. Exactly equal to 1 and 2. It is total. What about injective? We got A and C over here, completely no duplicates, completely unique without any duplicates. It is injective. What about surjective? A and C, you can see the range of that is actually A and C. Sorry. The range of that is actually equal to A and C, not equal to A, B, and C. So it is not surjective. So in conclusion, it is not a member of the bijection between these two sets, right? It is not. Right? So that's why it's really important again for you to see this symbol over here, the bijection. It is not because it is not surjective, even though it is total and injective. All right, hopefully you're okay with the bijection and also about the injection and also surjection and also total function, partial function. We talked about so many things so far this week. All right, so that's the example I just walked through together with you. And then the only thing we want to look at is the synthetical characters, the ASCII character, right? So this part over here is about being total. And this part is about being injective. And this part, the double head over here, especially this part here, is about being surjective because it's more over the range. All right. So that's about all the three functions, that special kind of function that we talk about. Think about what we have got so far this week. We talk about functional property, and we talk about partial function versus total function. We talk about relational image versus functional application. We talk about injective function, surjective function, and bijective function, right? We talk about many concepts over here. They're somehow related, but gotta be sure exactly how to distinguish between them, compare and contrast. Review the example if needed, and then to really conclude your math review, we got 2 more slides to really consider, and I would like to do 2 exercises together with you. Let's now go over one by one.